didn't count President's Day off, and so she didn't mean to be on a white day. Believe me. Okay. So, cylindrical shell method. Yes. Whoa, dude. I don't think we need little red big dots. This particular method, well, you'll see here in a second, why sometimes this method won't work. And you'll see here in a moment why this method sometimes does not work. Guess we'll have red. If I splash something up there, like this, with a function f up top, and a function g down below, and we, say, chop it off between two horizontal or two vertical lines here, and I say, okay, I want to take that area, but I want to take that area and I want to revolve it around the y-axis. So if I want to come around the y-axis, would that be a problem with the disk method?
There's like 4 functions that work.
Oh, boogers, it still doesn't work. Darn that thing. Okay, well, yeah, but if I did disk method, which way would my rectangle have to sit?
That's impossible. They'd have to sit this way, sideways.
Yeah, because if you're doing disk method, you have to be perpendicular to what you're going around. So if I drew my rectangle in here perpendicular, well, okay, right here, okay, I'd be thinking right-hand function minus left-hand function. It would be line minus line. But what happens when I get up here? I would be hitting, the curve would be hitting itself. I mean, it's just not going to work because it's not going to follow the curve at all. So if you were doing y-axis here, this method just is not possible. So they went, oh, well, which way would it work better to have my rectangles? If they were up and vertical up and down, if my rectangles were going up and down, wouldn't they be then taking in all the changes in the two functions? So yeah, they said, okay, we really want this particular situation, we need our rectangle to be parallel to our axis. That's why I was emphasizing perpendicular earlier. In this particular case, the rectangle is parallel to the axis. Now, the question is, what shape do you get if you revolve that rectangle?
You get a donut with a weird hump in the middle.
I got a donut with a weird hump. Anybody else want to give me
that one word with the A. An analyst.
an analyst?
Sounds like Luke now with the and he went like this, he was just like apogee.
You got the right answer.
Okay, I'm not sure I heard a really good description of what this might be, so we'll try it this way. If this is my...
Okay, it's a donut that wasn't cooked all the way, so it kind of oozed out.
Okay, but I'm not seeing a donut.
Yeah, that one.
What do you mean by it looks like a shell? Oh, she thinks it looks like, okay, seashell. Anybody else?
I figured the shell was in the line.
Okay, I'm going to revolve the rectangle so you see what the rectangle makes.
Oh, it's a shell.
It's a shell. It's got a hole down
Like
the
an
center,
onion.
but
Like an
the
onion.
reason it's called cylindrical, it's a cylinder, it's a can, but it's totally got a hole in the middle. Sometimes they call this the toilet paper method, because it kind of looks like a roll of toilet paper. But with not, this has got a much bigger hole in it. But it changes. That rectangle was, if you look at how far that rectangle was from the y-axis, but if I move the rectangle, in here so it was much closer, and then I revolve it,
Smaller.
I get smaller shells. So what I'm actually going to have, let me move the shells. I have that small shell, and then the next rectangle would be a shell around it, and the next rectangle is a shell around it. So you have shells and shells and shells.
It's like an onion.
Yeah, kind of. Yeah, it's got layers. So you just have more and more and more shells all in one inside each other. And what we're going to do is we're going to sum up the volume of those shells.
Can you do the whole region?
Yes, I can do the whole region. It's just a big empty bowl.
That's exactly what we did last.
Kind of very similar. Well, if you notice that last time it was basically the same shape, we just went around the other axis.
Can we do the functions that we have?
Unfortunately, this one does not let me pick. I don't have one where it lets you pick the function. You put the function in and see what you get. Because it's fairly complicated. Now, I have not played with it. Your calculators have 3D graphing. I have not taken time to play with the 3D graphing. I don't know if they can revolve this.
I'm trying this. Where's that?
On there somewhere. It's not something I've been too terribly worried about. Okay, our big question is, though, all right, if this thing is going to be a shell, if we're going to have this shell here, get myself a cylinder first, and it's a shell, how does one get the volume of a shell like that? Kind of, sort of. Okay, imagine this piece of paper here, rolled up, is my shell. What happens if you take the shell and you cut it open, and then you unfold it and lay it out flat? Then it's just a rectangle, isn't it? Except it's got some thickness to it. So if you cut it open and lay it out flat, yep, you're going to get a rectangle, but you have to have some thickness involved. So we're going to attempt to draw. Okay. So it's just going to be, I think of it as a little thick slab. Right. So how do you find the volume of that little thick slab? Okay. Technically, it would be length times width times height.
2 pi r squared h.
Okay. So, all right, let's do one at a time. Length, how long is it? Isn't it circumference? Because it's how long it was going around the circle. So the length is circumference. Circumference is 2 pi r. Okay. The height of the height is being controlled by what? The height is how high the rectangle is, and what's controlling how tall the rectangle is? The function. Function minus function is giving you how high it is. Okay, so the height is function minus function. Okay, then the width is how thick it is. The thickness is however thick. I didn't draw mine very straight. The thickness is how thick the rectangle is, isn't it? What do we usually call that little thickness of the rectangle? Dx. It's the change in x. That's always how much the x is getting closer. That's the change in x. So the thickness, if the thickness is dx, if you multiply all those things together, length times width times height, okay, I would throw the 2 pi out front. I'd have the r times the f minus g times the dx, and then I want to sum up all those different little shells that are inside each other. So I would integrate it from a to b. And that's your formula for the shell method. I like this method because there's nothing squared. I don't have to square anything. Now, the good news is everything else applies the same. If your rectangle is vertical, then you know you're doing top minus bottom. You know you're going to have your equations in what form? When they're top minus bottom, you're going to have normal y equals a bunch of x's for your functions, so therefore you're going to have x's in your problem. All those rules stay the same. Everything we've been doing did not change here as far as how you set all that up. The only thing is you're using a different formula, and you have to know that your rectangle lays in there parallel to what you're going around. Everything else is identical to what it was. I've not changed a thing. That's the good news. Okay, so let us actually proceed to try one of these puppies. So we'll start with something not anything too terribly complicated to graph, because my purpose here is to get you to learn the method, not spend life graphing. So, and this one is going around the y-axis. All right, how do I graph x cubed? Or do you want to graph that first? Do you want to graph the lines first? The lines do give you some boundary. It doesn't really matter. So I would need to graph y equals 1, which would be horizontal. Still in red. X equals 2 would be vertical. And then x cubed would be our favorite parabola. That starts where? 0, 0, 1, 1, 2, 8. 1, 2, 3, 4, 5, 6, 7, 8, and we're going to hit. So do I really need to draw the bottom of the parabola? I think we found our region. So you could draw the bottom of the parabola if you want to, just for practice and good fun, but not going to let me get in there that soon. So, okay. So that's my little area, and I'm going around the y-axis. So thank you. You just took the words out of my mouth. That's what I wanted to know. My rectangle has to be parallel. Is my rectangle vertical or is it my rectangle horizontal? To be parallel to the y-axis. We are going around the y-axis, so I am going to be vertical, up and down. Okay. So you can see, you're going to do top minus bottom. Okay. When I see a vertical rectangle, I think, oh, everything's normal. Normal equations are y equals, it's just normal, period. It's not everything going sideways. So, all right, we'll need to rewrite our formula, which was 2 pi times the radius, function minus function, times dx. Okay. I'm going to tell you to skip the radius for a moment. I need you to get the function minus function in there first. Because which function's on top of the rectangle, which function's on the bottom of the rectangle. Well, you have Scrabble is on top. So minus 1. Yeah, the horizontal line is at 1. So we have x cubed minus 1. And then, okay, that's my functions. Now here's the radius. The radius is the distance from what you're going around, the y-axis, to wherever the rectangle is. So, in this particular instance, my radius would be from the y-axis over to the rectangle. It's whatever that distance is. The little black rectangle in there. No, because is it just that one rectangle? No, there'd be a rectangle farther over. There'd be another rectangle over here and another rectangle over here. So, my rectangle is, all the rectangles are at a certain x-coordinate. Because wouldn't it be the x-coordinate measured from 0 from the y-axis over? Wouldn't that just be an x-coordinate? So my rectangles are at every x-coordinate in between 1 and 2. So therefore, my radius is just x. Whoops, can't see that. It's just x. I'm going over to whatever x-coordinate it is. And where am I going to put the from 1 to 2? And yeah, it's just your limits on your integration. So your radius is just going to be x.
Always x.
Or y, if you're using y as a problem, as long as you're going around the x or y axis. Now, if we go around some other line, we'll have to change our radius slightly. But normally, yeah, it's just x or y if you're just going around a normal x or y axis. Okay, and then from there, any big deal to integrate that? Okay. Do you all want to see me integrate this by hand, or are you willing? Actually, I don't even know the answer. That's not good.
You better integrate by hand.
Fine. You want to integrate by hand?
Yep. Do it.
All right. That'd be x to the 4th minus x. If I integrate it, power rule, x to the 5th over 5, x squared over 2, from 1 to 2. More room. And then if I put 2 in there, that's going to be 32/5 minus 2. Subtract parentheses, put a 1 in there, is 1/5 minus a half. Change my signs. That'd be a negative 1/5 and a positive half. And then since I'm doing it by hand and I don't even have a calculator to help me, I would do 32/5 minus 1/5 is 31/5. And I would combine negative 2 plus a half, would be a negative 3/2. I would combine those two, and then I'm going to have to do a common denominator. 62/10 minus 15/10 would be 47/10, I think, times 2 pi, which would give us 94, oh no, it would be 47/5. Because the 2 would cancel. Oops. So I would say I have 47/5, or 47 pi over 5 to be specific, units cubed because it's still volume.
So how do they prove this works? Do they get like a graduated cylinder and drop something in there and measure it?
Well, actually they proved it mathematically, but I'm sure they tried it physically as well. But they did.
Yeah, they can say they're right.
No, you can't. You can do a formal proof and prove that it will work.
I think they can say they're right, it doesn't sound wrong.
So,
But if they're the only person that knows how to do it, can anybody say they're wrong?
other mathematicians checked the proof and verified it for accuracy. And believe me, when somebody says, hey, I've discovered something new, a whole bunch of people are going to go, no, this can't be, and try to prove you wrong.
Yeah, you gotta remember, they all hate each other. They're all angry little nerds at each other.
Well, at that point in time,
You've done it before, you're no smarter than I am.
they were pretty competitive.
Angry little nerds.
What now? Oh, time, thank you.